So today, basically, what we'll do is that we will round up on all the things we have discussed about word embeddings. And by now, I hope you have got a good understanding of word embeddings and more importantly, why it is essential. So I will make the final collection today. That is how word embeddings are utilized in large language models. Is the first component, and it's a very important component. That is number one. But by and large, you have the entire idea. So I would expect that you would have tried different things with the code, etc., which you have shared. So if you have anything to discuss, that will make this session interesting. And because it will be basically a revision of all that we have been discussing all this time. And then lastly, I will show you LLM in action, English to Hindi translator, how it was built. And of course, it took a lot of time to build it. It took more than 5 days in total, but the final training round took around about 18 hours. So it's natural that I won't be able to show the entire training cycle, but I will show it on a very small scale, and you'll get the idea regarding how this is done. And then I also built a tool around it, so I will show the tool and how it works, so you can experience it. And then basically what we will do is that we will transition to the next phase of this program. That is, we need to discuss about transformers. So today I will introduce transformers, and we will get on to transformers from the next class onwards. Now I need to make a small announcement here that I will take a break in this particular program for 2 weeks, basically because my PhD classes for Indian knowledge systems have started, and we are having classes on Saturday and Sunday at 8 p.m. So today I'm skipping my class, but that will not be possible because I have to give my attendance also. So I will put a break on this program for 2 weeks, and then I will again rejoin after 2 weeks. So I hope that will be okay with you, and you will rejoin me at that stage. So that's something which we'll have to do because it's what do you call? Normally the classes are held on weekdays, but this time they have announced on Saturday and Sunday. So that's my situation. Okay, so let's get on now. Please interact so that we have a meaningful discussion. So now we started our journey where we treated every word as an atomic particle, and soon we realized that this is not the way we can teach a machine, because words have context, words have semantics, words have syntax, so everything is there. So it was not possible that we treat the word as an isolated entity standing on its own. Then it has got limited utility, and machine definitely cannot learn a language that way. And more importantly, what happens is that the models get limited by vocabulary, and that restriction is very binding on the models. So we had to think of different techniques, right? So now next what we did was that also we found that there are a number of nuances to how language is created. There are words which are used in different contexts. There are words which are used in different forms, and all of these go into forming a language model, and we need to find ways to make the machine understand all these nuances within the boundaries of mathematics, what is available to us. So I took you on this journey step by step, telling you what the challenges were, and how the challenges were overcome. And also another important thing which I tried to do with you guys is that I showed you everything from the first principle. That is, we discussed all the discussions that we have had so far have been from the first principle, where I opened up the neural networks and showed up the neural networks to you. So the neural network, what we are actually utilizing for learning a language, for the machine to learn a language, is not a black box for you, but it is actually open book, and you can understand the nuances, which gives you the idea regarding where to tweak, where to uh, modify, where to make decisions, etc. So this was the strategy, and uh, normally we would not go this way because what do you call? See, it overwhelms, especially people who are semi-technical or non-technical. But I took that route, and I hope it was useful to you guys. Okay. Nevertheless, so we found that we can no longer use words as single unit, and we then found a way that we break it up into meaningful units, and we call them subwords. And the subwords then, what do you call, made it easy for us to for the machine to learn many different words, and the vocabulary space suddenly increased. And this is the technique which is modern used in the modern LLMs. Okay. Now, you must have realized, and I emphasize this many number of times, the machine is basically looking at numbers. It does not perform any, it does not understand any relationship between words. So the word dog and a donkey and a feather and a book has got the same impact on its on understanding as anything else. Um, so it does not perform any inference here. It basically just discretization. It is then it is finding. We found different techniques, like it's finding what is happening in the neighborhood, and that was the basic thing. Then we expanded the neighborhood, and then try to give it context and try to give it semantics. So that is how we made the machine learn. So we saw the two extremes. One is dealing with the language at a word level. Now, it had its problems, basically because it was expensive, and it fails the moment it does not find something which we have taught him before. Then we went to the lowest level, that is character level. Okay, this was not expensive, but at the same time, dealing at the character level, it doesn't have any meaning. Individual characters make no meaning. So we found a midway that was using subwords. Oh, come on. And this made it perfectly possible for us to teach machines something useful. So so far we are clear, right? Are all of you clear about what we have done so far?
Yes, sir.
Yes, Papa.
Yes, Papa. Yeah.
Okay. Now, so then, what do you call? We saw that when I'm teaching the words, so we're basically tokenizing, and we instead of treating words, we say that we are dealing in tokens. So I also explained to you the commerce behind it. That when you're interacting with machine or LLMs in the practical world for audio work, you're dealing in tokens, and you're basically paying for tokens. And so how you optimize the use of tokens is basically going to determine how much expensive your utilization of LLMs is or is not. So many companies are realizing that, and what do you call? It is not just enough to give a co-pilot or something like that to the employees. It is also very important to what do you call, train them regarding what are the nuances, what are the tokens, and how to maximize the utility of LLM by minimizing the amount of tokens we interact. That is a number of input tokens we give and a number of output tokens we extract. And you understand some commerce that input tokens are less expensive, and output tokens normally cost about 3 to 4 times that much of the input tokens. So uh, uh, so all these nuances we have gone through. So we understand that we are dealing with tokens, and as far the machine is concerned, it's only numbers, and it does not understand anything beyond these numbers. And we have to somehow find a way that we form these numbers in such a suitable manner that the machine can understand and make a context out of it, and then it can learn our language. Okay. Then what do you call, we came down to the most important topic that we have been discussing for the past few weeks, that is we have to somehow make these numbers meaningful, and that's why we formed something known as the embedding layer. Embedding layer is that we used various techniques by which to make the embedding layer intelligent so that it gives the machine ability to learn things that we're doing. We've started with simple embeddings and we're going down to Elmo and BERT and all this kind of stuff where we not in BERT not only giving making the embeddings based on surroundings but also giving attention to what is immediately there, what is immediately beyond it, and all this kind of stuff. So this has been the basic topic of our discussion so far. And now we started with this discussion where we said we do a one-hot encoding, the simplest mechanism. But one-hot encoding basically means that I'm having no context at all. They are all independent things. But this is still useful. This is very much required. We understood that basically because when we formed embeddings, which are very highly sophisticated embeddings, like which this picture tries to depict. So when you have high dimension embeddings, then what happens is that how to pick out a single element, a single word, or a single token from it. We saw that we require one-hot encoding, where it becomes a lookup table. Basically, the embeddings become a lookup table, and we have to extract that. So nothing that we have discussed is not utilized in the modern world. Everything is required. That's why I chose the topics and I discussed them. And by unfolding it step by step, I hope I have given you the idea regarding how exactly to utilize it. And if you are going to formulate your own mechanisms, which some of you may, then you would know exactly which are the tools to utilize to achieve the goals what you're setting for yourself. Okay. Then what do you call? We saw various representations of this where we saw that we were able to represent a word and it is able to find context within itself, and it forms groupings, clusters, and all this kind of stuff, right? So we've done all these things. Now lastly, I come to the topic of discussion today, that is how to make a practical utility of all that we have learned so far. So far what we have seen is that in the last few demonstrations, I showed you that large language models are nothing but next word predictors. It is predicting one word at a time. And if I combine that effort by putting it in a loop, then it is able to do that continuously. It seems like it's generating sentences, etc. But so far, what we have done is that we have not really seen the LLM generating something. It has done sentiment analysis, it has done searching, semantic searching, and everything it has done, but it has not really done any kind of generation. Now, what is required for generation is that we require a transformer. So that is going to be our next topic of discussion in this particular program, where we will go into the nuances of how to make a transformer and what are the elements that build a transformer. But today I will introduce you to an already built transformer and how to this is practical way of utilizing technology that there are many circumstances or most circumstances, especially for small organization. Even whether you're a small organization or a big organization, you'll see that even if you have money, you may not have the resources. What is essential to make a meaningful transformer? So there are companies who are specialized in this, and they are building transformers. And then what is possible is that we have a technology which is called the transfer learning. So transfer learning. So in transfer learning, what I do is that I take a model which has already been created, and that creation of the model took a lot of effort, a lot of money, a lot of resources, and somebody had that and he did it. And then what I'm going to do is that I'm going to take off from where he has stopped. I will take his model and I will fine tune it to my specific requirement. This is normally the way most of the applications are built. Like even what has happened, how the LLMs are built is that first there's a concept which is created. Some scientists will create a concept, and then based on that concept, they will collect data and they will train a model. So they will collect the necessary data and they will train a model. And after this stage, you get the models like we have today, like what do you call, you get GPT or you get BART or whatever. These models are created. Now, do you understand? Like I've discussed with you that these to create this model, it takes enormous amount of money, and that is one of the reasons why not many people can get into the business of LLMs, because you may have the knowledge of technology, but you do not have the money to put in and create a viable model. But what is possible in 90 to 95% cases is that I take these models which is already been trained, and I fine tune it to my specific uh, what do you call business requirement. So this is exactly what I'm going to do today. Is I'm going to take a um, already trained model, and I'm going to fine tune it for a specific activity, and my activity is to translate from English to Hindi. So is the context clear to all of you?
Yes.
Yes, Parth.
Yes.
Okay. So now let's get on to that. I will get back to the presentation after we go through the code. Um, so here it is. Now, like I told you, this takes a lot of time to build. It takes many days. So what I'll do is that I will perform this action entirely on a very small data set. I will show you what goes into making it. But before I do that, let me show you even this model which you are seeing on the screen is created on a very small data set. But let's see how it performs. So when I try to tell him to translate, you see the results are like this. When I say hello, it says hello. It's okay. That's good. When I say how are you, it says tum kaise ho. That's also good. I'm learning machine learning. My machine सीखने के लिए तैयार हूँ. This is not so correct, right? Because the machines, because I've done it on a limited data set. But look at this. This book is about word embedding. ये पुस्तक, this is also not so good actually. But it does much better. But see here, it learns. When you're saying we are studying translation, हम अनुवाद पढ़ रहे हैं. This is very correct Hindi actually. And look at this. This is even better. She is reading a book. So it says that वो किताब पढ़ रही है. See, it has understood the gender. So it's actually a pretty good model. So now let's see how to make this. So I need to install the required libraries, and what do you call? I show the versions of the libraries which is there. I'll share this notebook with you guys, so no need to worry about that. And I could not train this model fully on my own machine, though it's a fairly powerful machine. I had to take the help of AWS, where I took a large EC2 setup with NVIDIA GPUs, etc., and a fairly large amount of memory also. And then it was possible to train the model, and that training also took around about 18 hours. Okay, so this is what I have. Like you are seeing that I'm using GPUs, I'm using CUDA, and this is Apple. So it has got its own version. It's metal, so it has got limitations. So you must be careful when you're using Apple machines for doing machine learning. Okay. Now what I do is that I've taken a data set from Hugging Face. It is IIT Bombay's English to Hindi translation. So when I load this data set, I will change this number to 1000, then it become practical. Okay. This is 500. This is 250. Now it is practical. We can do this. So now I load my data set. So you see the data set has got English words and its corresponding Hindi translations. So I'm going to use this data for training my model. Actually, not training my model. I am going to use a model. I'm going to fine tune that model using this data. And I'm doing a specific task where I'm doing building a model for translation from English to Hindi. You have to be very specific. It cannot be I cannot do anything and everything with this. Now the model which I'm going to fine tune is this one. This is again from what do you call Hugging Face. So this is the model which I'm going to fine tune, and uh, I've taken a tokenizer, etc. I've taken a tokenizer, and then I instantiate this from Hugging Face. So, okay, it basically builds a 512 element embedding sequences. So now I do the tokenization of the data. Yes, who is it? Deva?
Yes, Partha. So, Partha, any reason why you took that specific pre-trained model? Why not like Llama 3B or which are available for us also, right? So, why can't we use that? Any reason?
No, reason was simple. See, the thing is that it was not, intention was not to just create a model for training over learning purpose. I actually want to build a tool. So actually, when I build a tool, this is the tool which I have, and this I'm implementing on Hugging Face. So now since I was sure that I only have the platform Hugging Face for implementing this model. So I wanted something native to it. That is the reason why I took this model. I could have done it in Llama.
So,
Yeah.
okay. So, what I just wanted to understand what would be the approach that we need to take when we decide, okay, specific model to choose as our transfer learning, right? So, how do we evaluate that? Okay, this specific model would be a best for our use case. Like, how did you approach? At least the approach, if you can give us.
Yeah, see, the approach is very simple. The thing is that, first of all, I should have a model which is close to what my application area is, like, So, what do you call? My application area was very specific. That is, I want to do a English to Hindi translation. So so I required a model which has been trained on something very similar, similar kind of application. So this model, if you notice that it is specifically made for English to Hindi. That is number one. Second thing is that like I told you, my implementation strategy was a decision point as to where I'm going to implement it. So as I was going to implement it on Hugging Face environment, I required something native to that. Of course, now the thing is that the cost is another factor, but cost is not come into picture basically simply because um, cost did come into picture. Now I have a Hugging Face account, and as a result of which, see, the thing is that I have implemented the Hugging Face interface, the token I have provided him, and every time I'm using this particular thing to demonstrate anything to you guys. What is happening is that I'm actually paying Hugging Face some amount of money. Now that affordability I have with Hugging Face, now the same question will come into place if I take anything from Facebook or Llama or whatever, Facebook's Llama or whatever, and I have to have an account and I have to be paying the subscription, etc. So since I'm already paying Hugging Face, I did not go for any of those subscriptions, and I'm happy with what I have right now. So all these decision points come into picture because yeah, and most important thing, like apart from all technical decisions, commercial decisions are very important considerations when you're making a choice of a model and architecture. Right? Does it answer your question?
Yes. Yeah. Kind of. Yes. Yeah. Okay.
Okay. Okay. So now let's initialize this. So I've done this. Now I do minimalistic pre-processing. I do not do too much of pre-processing. Except for taking out long sentences and long sequences, I do not do any of the pre-processing. And having done that, because I do not want to lose the raw messages inside the data, what is there. Now this is a data collector which is required. The data collector basically to do tokenization and then apply the model. This is the pipeline which I'm creating. This is simple. And once I've done that, now this is very important to understand. Now, when I'm making the model, you know that I require a loss function. The loss function in a neural network is basically how close I am to what do you call to the in a supervised learning setup, how close I am to the training data which I'm providing to the machine to learn. Now here I've taken a different approach. What I've done is that there is something called a blue score. Now blue score is a international standard by which we judge how effective a translation model is. Okay, the blue score runs from 0 to 100. So now if I have a blue score of around about 50 or 60, then I can understand that my translation is happening at a very good efficiency and good quality. Now, so instead of trying to evaluate uh, how close my input and outputs are, uh, I'm basically checking at every stage whether my blue score is improving or not. If my blue score is improving, then I know that my model is learning, and if it is improving in the right direction, then I know that I will get an effective model at the end of the story. So this is what is the metric I set up for checking the effectiveness of my model. So now this is done, and then this is the training parameters. This you understand from a neural network point of view, like what do you call, what is going to be the learning rate, how many epochs I will do, and so these are something which these parameters are specific to the model which I have taken, and what do you call, I basically set them up. So this part is specific to the model. So the model, whatever internals, you have to understand that, and then what do you call, apply those parameters. Then I set up my trainer. Now trainer, I'm doing a training, I'm doing a validation, and also I've implemented early stop in case the learnings doesn't proceed. Then you stop. Now early stop, you must understand this. Basically, you see that I'm saying early stop, and I'm setting something known as patience. Okay, the patience basically means it works like this. That is, supposing my evaluation parameter is something X, and I run my epoch. And after running my epoch, the evaluation criteria comes out to be 2, and then I run my epoch for the second time, and the evaluation comes out to be 4. Now I run the thing for the third time, and the evaluation criteria comes down to 3. And I run it for the fourth time, and the evaluation criteria stays at 3. So now if you see that in 2 epochs I have made no improvement. So in that case, my patience level of 2 will say that now you stop, because you're not seeing any improvement. So it's better you use the step where you got the maximum performance and you utilize that. So this is the criteria by which I can say, okay, fine, a machine learning model can continue to learn, or I can stop the training, because any further training will not result in anything useful. Any questions here? Did you understand?
Yes, Partha.
Yes, Partha, yeah.
Okay. Now here is where I'm doing the fine tuning. I'm not training, like a model is already trained, and here I'm doing a fine tuning. So you can see, I just for experience I made a very small data set, so you can experience how the training happens. So it will do a 300 rounds. So after one epoch of training, it will do a validation. So it's doing a validation. After the validation, it will give you a blue score. Just observe that. Okay, so you got a blue score. Now the blue score is 8. It means it is okay. Translation is not a very good translation, but nevertheless, it works. Now I'm going to be monitoring this blue score for the purpose of early stopping. If the blue score stops improving, then I will stop my training, and I'll say, okay, fine, whatever you've got trained, that much is sufficient for me. So now you see that it's reached the second round of validation. It will do that, and it will give you a blue score. Okay, let this training perform. It will not take much time because I've reduced the data set to 1000 data points only. But actually, the complete data set is around about 1.6 million data points. So it's a huge data set. And I will show you the results so that you can judge whether it is good or bad. So let's just wait for the training to happen. And in the meanwhile, if you want any discussion while the training is happening, you can we can do that.
Arthur, maybe this is out of context question. So I just wanted to understand how different it is from a fine tuning versus the rack system. Like one of the use cases that we are working on, we have a model, we have a domain specific documents available. Uh, as you know, training the model or fine tuning the model for this new document is not that easy. It's a cost effective also. So we see, okay, can I enhance the model's capability by using a rack system? So how different is it? So is it okay to continue to be in the rack system, or is it necessary that, okay, at some point I should be doing fine tuning and create a new model out of the base one for this new documents that I have?
No, see the rack system. The concept is slightly different. Rack system, how it works is like this. What do you call? Basically, you have a trained model, just like I have in the trained model here, and you have a particular application, so you can use your minimalistic data to fine tune the already available trained model. And then after fine tuning it understands the context of the problem. And then you say that apart from searching within your own data set, you also search inside the database which I'm providing you. So this is the retrieval augmented generation part. This like now normally what will happen is that the user will put a query. So here he puts a query, and after he puts a query, the model will search within its own data set and try to generate an answer, and then it will provide the answer. So this is the normal system. And RAG, what is happening is the RAG, what you're creating is that it is what is first step is that I get a query. And after I get a query, it will understand the query. It interprets it. And after understanding the query, it will make a hit to your database, right? And it will make a hit to your database, and it will retrieve all the relevant information based on the understanding of the query. And that information, when it comes back, this information will be used for reply generation, response generation, or inference, and that inference will come back to you. So actually, what do you call? You're not really training, and you're not really going to be training on the specific data. Why you cannot train on the specific data is simply because this whole architecture you made so that you can keep adding to this database, right? You can keep adding.
Yes, so because I'm seeing in one of my use cases that, okay, the domain specific data keep increasing on month based on for example, the quarter documents that are generated, financial documents that gets generated, so that I don't have to train my LLM for doing any query and do a lookup and give me that. So it's easy for me to put a rack system on that, right?
Yes.
So that approach is still, can I assume that from the architecture point of view, that system is still a fail-proof system that I can use to an extent?
Your decision on making rack system for this particular application is absolutely correct. Now, what you need to augment, like what I'm trying to tell you, is that first of all, find a suitable model which applies to your particular use case, and then find suitable data, not this data. Find suitable data for fine tuning. What the data what you select for fine tuning should be applicable for making inferences from the ultimate data what you're going to give him. Okay. Say for example, let's say I want to make a chatbot for ancient Indian text. So I select a particular model which is able to work between English and Sanskrit, and I'm going to fine tune it. To fine tune it, what I will do is that I will find suitable data. What can be a suitable data? I can find suitable digitized forms of ancient Indian texts like Vedas and Puranas and Upanishads and all this kind of stuff. So using a corpus of that, I will fine tune my model saying that you understand this particular kind of data. So just because English is also vast, Sanskrit is also vast. I'm narrowing down the perspective into a specific use case when I'm saying that I'm going to be only talking about ancient Indian text, so you only understand this. After I do that, then I implement my RAG where I put a database where I will put in all the different corpuses which I can get my hands on with respect to answering questions regarding ancient regarding uh, Vedic queries. So if I do this, then this entire model will work very effectively. Right? Did you understand?
So what it means is basically, say, if I take a vanilla LLM system which is trained on English corpus. So now, if I want to upgrade this for, say, financial terminologies and stuff, so that it can understand financial things, I want to make sure that okay, a data corpus of financial related thing is what I'll fine tune. Then I take a company specific financial documents as my rack system, so that I can use this as a base. So this way, this system is be able to, my LLM will be able to understand the financial terms, and it will be able to make a better judgment to go get a required references from the RAG system and retrieve truthful answers for me, so that it gives me accurate answers, right? That's the
Yes, your understanding is absolutely correct. Take a LLM which understands English language well, and then take data from finance world. You can get a lot of data regarding finance world from various sources like Economic Times or things like that. Fine tune the model based on that data, that specific data regarding finance data, and then you build a database of your company specific data, and put the LLM on a RAG architecture to retrieve information from here, and so you will get a perfect system.
Okay, understood. Thank you.
Yeah, anything else coming to anyone's mind? You see that the training has stopped after 4 epochs because it is not improving too much. You can see the patience level here. It is patience is 2, so here it was 8.17, and then it dropped continuously twice. So it says I've run out of patience, so I will stick to 8.17, and that's how the model has stopped training. Right, now I go on to evaluate my model. Okay, it has done some evaluation, and it's getting an evaluation blue of 12, which is not so bad. But it's going to be very naive. Now I save my model. This step is important. After you save your model, see what it is, how it has saved the model. So I will show you what are the components where what gets saved. So this is the translation model. So you see that you take a particular checkpoint, this checkpoint. Now all of these files, not everything, but or most of these things is actually containing your model. So now you got to download these components very carefully. And when I'm going to set up a tool like this, now here you see that I have a persistent storage for this. So you see I have a persistent storage. So these blue color ones are the persistent storage. So in this storage, I am bringing in all those files which are there as a part of the model, and then I'm persisting it. So the advantage of this is that what I've done is that 1 minute. I will show you the code also. 1 minute, Pasha Setu. Yeah, this is the one. See, what I'm doing is, in this, have I logged out? No, I'm not logged out. Yeah, files. See, what I'm doing is, when I start my model, I check if the model is available in my persistent storage or not. If it is not available, then I download the latest model which I have stored in my Google Drive. Okay, and this happens lazily because only when I need to translate do I download the model. So it happens very lazily. But this is important. The models, after you create the model, you have to save the model files, and you have to ensure that this is available in the application where you're going to be utilizing it. So it includes the tokenizer model, everything you have to get it into the memory, right? So this step is very vital. After I've saved it, then it comes to inference, to do the inference. Now I'm doing the inference. I built a function for that, and now you see that based on the small training, it is still able to do some of the jobs very correctly, right? Do you think it's useful?
Yeah, based on the training data, pretty accurate.
Not so bad.
Like it could not translate embeddings and so on, but otherwise,
Yeah, look at this. What do you call this? Is a 1.6 million data set, and I showed you that I'm only utilizing 1,000 data points. So it's a very minute amount of data what I have utilized for training it. You see, where did it go? Yeah, see, out of 1.6 million, I'm only using 1,000. So it is not so bad actually. Now let's see this in action in the actual tool where it was built on 1.6 million data points. So let's see how it works. So this model works pretty well for small pieces of English text. Let's take, for example, I take this much amount of text, a small text, and I put it here, and then let's see what it does. You want to try this tool?
Yes, Partha.
I've given it in the chat. It is doing a lazy load. That's why you now check here. Tell me whether it has done a good job or not.
Sir, if you could put the same sentences that we saw in the notebook, so we can have a comparison.
Okay. But look at this. At random, I have given absolutely unseen data and it has done a very good job actually. What would you say?
Yes, sir, it's good.
Yes, only one mistake. Otherwise, everything is good.
Yeah. Okay. Like you said, I will utilize the stuff from the notebook, especially where it has made a mistake. So let me go ahead. Yeah. Okay, we are studying translation the language. This is the one. Language models with electrical embeddings. Right. Replace this. It's doing something. Translation aborted. Detected input language. Okay, it does something. If it is non-English, then it will not do the translation. But this is English. Why it is saying this is non-English? Let's try another one. Okay, for detecting language, I have used a library, and that library sometimes misbehaves. So,
Partha, this is working on my system, and
yeah,
it correctly translated.
okay. It is pretty good. You see, it got it right here.
I too tried it. It works. It works.
It works. Now, see the problem. What will happen? Now, supposing I give it a long text. Okay, I give it a long text. Then see what happens. You see, it has stopped all of a sudden. And there are many problems here in this. First of all, when it comes to proper nouns like Ganesh, it cannot understand. Okay, especially because this is an English name, a Indian name. Now, this program, I will show you the code also. This program basically tries to understand if it's a name using name entity relationships in ER, and in case it's a proper noun, it will retain the proper noun as it is. But that part of the program is not working very well. There's a lot of work I have to do on this. Now you saw that it truncated the output, right? It truncated the output basically because I have told him to generate 256 tokens as output. Okay, now see here the English in the translation. Yeah, input is 512 and output is 256. Yes, that is why after this many number of tokens it will stop generating tokens. So there is a lot of work which is still remaining on this particular program before it starts working properly. But I can do a few shortcuts to do this. The thing is that when it comes to long inputs, what I can do is that I can break up the input into sentences, and then sentence by sentence, if I send it across to this translator, it will be able to translate the entire long sequences also. So that is a modification which I do, but that's not a very good way to do the things. But that works as a solution. So you can think about these kind of innovations after you have a decent model, right? And I showed you the number of things which is not working. For example, I'll show the name entity part. Yeah, see here. This is a name entity part. So I'm using a model for this also. I'm using a BERT model for name entity identification. And it is, if I identify a name entity, I just restore the original entity back into its place. So that is what it should have done, but it doesn't do that. It falters at this particular stage, right? But anyway, I think I could give you an idea regarding how to create a translator. Do you think my assumption is correct at that point?
Yes, Partha. Yeah, we have a base. Yes.
Yes, sir.
And after I share this code with you, you guys should be able to further enhance it, do all kinds of experiments with it. I will share this code, and so that you can continue experiments. So here it is, LLM and the translator code. Okay, let me know when you have downloaded it. So that's And if you're very serious about doing something like this, then try out a cloud platform to train this, because there are a lot of nuances which you require to take care of when you're going to utilize a cloud platform. It is not as simple as using a Google Colab. Um, uh, you'll have to set up a lot of parameters like security and all this kind of stuff, and private key, public key, etc., and all that. So it is a good learning. So do step by step and go. Be careful, because there are risks also. There are always people watching for any weakness what you're setting up in the cloud, and they can immediately exploit it, and that can land you into a huge financial loss. So be careful, and when you're doing those experiments. Okay, fine. So I have done for today. If you have any questions, I can take that. And
yes, but I have one question actually. So this is more on to do with how do we evaluate the model now? Now that you have a specific model, so say this required some kind of an expertise. One level is manually you're just trying to check what I gave and what is expected answer. So you'll be manually doing it. But is there a way of large scale evaluation if I want to do?
Yes.
Not just for this, because I keep hearing something like if you have your own LLM that you have designed, how do I make sure that it is truthfulness and it is not hallucinating compared to the bigger bigger models, right? So because if I say, for example, I take a Llama 3B, a 3 billion token model, that may be very good for my use case, because the way I'm putting this model might be a small box, right? Hardware wise and stuff. So now if I have a way to make sure that, okay, whatever Llama 3B is providing as a response, it's a high quality response for my use case compared to the Llama 8B kind of a solution, right? So I get this always from the solution architect point of view that, okay, I run something like a challenger kind of a thing. Okay, one is a reference and the other one is more like a challenger who will giving you a response. You compare it with them. So those are things that are there, but I just wanted to know from your point of view, how do we evaluate the model that we have in hand?
Yes, the thing is that evaluation always, it goes by a standard mechanism. Evaluation always happens by identifying a metric and then comparing your results against the metric, right? Now, for example, if I want to evaluate my model here, while training, I use Blue Score. I can use the same Blue Score metrics for my evaluation also. That is, every time I'm giving input to my model and it's generating output, I calculate the Blue Score. So if I aggregate all the Blue Scores over, let's say 100 tests or 200 or 1000 tests, then I will know what is the average Blue Score I'm getting. Now the Blue Score has got scales. Like if my Blue Score is coming out to be between 20 to 50, then I know that my model is moderate. If it's coming out to be 50 to 80, then I know that my model is quite good. And if it is greater than 80, then I know my model is exceptional. So in my particular case, where translation is the only thing, my suitable metrics is a Blue Score, right? I can evaluate against this. Now, if you're like, for example, you're looking at a financial chatbot. Now you're going to find out what's the suitable metric for evaluating the output, and then in a batch you keep on giving inputs and check against the metrics what is the average rating you're getting, which will give you idea regarding how good or how bad your model is, right?
Okay.
Anything else coming to your mind?
None from me, Partha.
Okay, then like I told you, I will take a break for 2 weeks. I'll complete my classes for PhD and I will join you back. I will make the announcement regarding the session after that, and we'll continue. So I hope you guys are finding these sessions useful, and I'm trying my best to transfer whatever knowledge I have, and I will continue to do that. Right?
Yeah, very much, Partha, actually, yes.
Yeah, thanks a lot,
Nice
Partha, for
sessions
this.
that we do, yeah.
Yeah. Okay. I will continue my effort, and I'm very
Thank
grateful
you.
for you guys that you are keeping on joining and encouraging. Because I'm also learning in the process from your questions and from interactions. It's good for me. So thank you very much. Have a nice weekend. And
are we meeting next week, or is the break after that?
No, I will take a break for 2 weeks. I require that. I have to join my
Okay,
class.
next week we don't have class.
Next week and the week
Next 2
after that we
weeks.
don't have. After that I
Okay.
will join back.
Okay, thank you, sir.
Okay.
Yeah, we'll
Thank
keep on looking at the notifications from your end.
Yeah.
LinkedIn, yeah. We'll watch out LinkedIn, yeah.
I will announce on LinkedIn, definitely.
Yeah.
Right.
Thank you.
Thank you. Thank you, sir.
Bye.
Thanks.
Good night.
Bye-bye.